Hello, everyone. How's everybody doing? I hope you're doing fine. We have a very exciting day today. We've covered what so far? We've covered zero-dimensional points. That wasn't that exciting. Uh, One-dimensional lines. Can't beat that. Um, then we went off to um, two-dimensional planes, and we ended up with one of the subjects of today, which is um, nothing. Now, how exciting is that? That's a good series, right? Anyways, today we're going to add one more bit to that nothing. We're going to do nothing, but we're going to add oblivion to it. We're going to add infinity. And it's a valid question because you talk about nothing. The question is nothing infinite? Okay, but before we move on, I just want to remind everyone that we have a conference, 7th Rational Physics Conference in Bora, Sweden on June the 8th, 2019. Okay, so we hope to see some of you there. Okay, and you're going to meet some very interesting people with whom you can exchange your ideas, your fantastic theories. Okay, um, nothing. Why did we get into the subject of nothing? Well, we have the fine gentleman. His name is Larry Krauss, and he's a mathematical physicist. I call him abstracist, but fine. They call themselves mathematical physicists. He wrote a book, and it says that he can create something from nothing, the universe from nothing. This is how it all started. It started here. Oh, sorry, wrong one. There it is. A universe from nothing. And the question is whether that is even possible. Okay? And the question is whether he really meant that. Turns out that there are, some problems with what Larry is proposing. And I went through them last time. And it goes something like this. It says that universe, according to Larry, he redefined the word. He says, look, universe is just another galaxy that we can't see or touch or never will be able to interact with. And so he calls that a universe. He says that's the pragmatic or operational definition of universe. And the problem with that is that, this other galaxy shares the same space that we do. So it's a cluster of matter that has the same space, continuous space to us. In other words, there is nothing separating us from them other than space, and we share the same space. And so if we define universe as matter plus space, well, if we have the same space, then that other galaxy is part of our universe. In fact, he kind of agrees to that when he says that all these galaxies sprang from the same Big Bang. So who cares if we don't interact with them? It's the same universe simply because we have the same space and we're defining universe as matter and space. Otherwise, he would have to define universe, and he's kind of defining it as cluster of matter with which we don't interact. Okay, so we have a problem there with his definition of universe. But a bigger problem comes with the word nothing. According to Krauss, nothing is equal to something. And he always ends up with something, no matter how he twists and turns it. So, this notion that the universe sprang from nothing, turns out the universe sprang from something. And he calls this nothingness energy, whatever energy is. Well, Richard Feynman tells us that no one has any idea what energy is. For sure, energy is a concept because we put units and numbers with it. So it's an abstract concept, it's a quantity, mathematical quantity. So he says it sprang from this quantity, this mathematical quantity. And he says that he takes this positive energy, he adds it up with negative energy, and he forms nothing. Okay, and then he takes this nothing, he can break it up also into negative and positive energy, which somehow morphs into negative and positive particles. How a concept becomes a particle? Well, I've got a little GIF here to show you of how that magic is done. Here you have energy colliding, positive and negative, and turns into a particle. Now, how's that for magic? We have an abstract concept, and it turns into a virtual particle. Isn't that neat? Well, that's essentially what these people are saying. These people are saying that you can take positive energy plus negative energy and somehow come up with a particle, a virtual particle that lasts as long as the mathematician needs it and then goes back into being space, I guess, right? Nothing. And, and they add to that, oh, by the way, empty space is not empty because it's got all these fields, vibrating fields in there. And so you never end up with nothing. You always end up with something. So this, sales pitch that the universe from nothing, no, not true. Not in quantum mechanics or general relativity. In mathematical physics, it's the universe from something. And the religious folk obviously like that because they say, you can't produce something from nothing. You need God. And so, this upsets the mathematical physicists because they want to believe that if they introduce God, they're introducing superstition and magic. And they say, no, we don't need that. We do it scientifically. And it turns out that they've got more superstition, more magic, more witchcraft than the religious folk. Okay, but it's a valid question whether the universe is infinite, whether this nothingness, assuming there's a nothingness, right, is infinite. If there is nothing out there, what is it? What's the definition? And if there is such a thing, is it infinite? But even if you take the point of view that nothing is something, you can talk maybe about the ether, just a bunch of particles, I guess. Is that infinite? I mean, is there a limit to that? Does it stop somewhere or does it continue forever? Right? And definitions are important here. They're important because you got to know what they're referring to. Are they referring to an object? You can say ball. Ball is finite, right? But you can walk around the ball forever, right? Nothing stops you because there's no fence in the surface of the ball. And so the question is when you talk about infinity, or as the mathematicians like to talk about it, unbounded, they say, space time is finite but unbounded. And what are they referring to? You mean it's finite and infinite? Well, they're referring to two different things, and that's going to pop up in my discussion today. And here's a little GIF that illustrates that. Here's a guy walking around the finite Earth. He's walking incessantly. And to say that the Earth is finite and but unbounded is wrong. What the guy is really saying is that the earth is finite and the walking is incessant, or even perpetual, if you wish. In other words, what we're saying is that we're comparing apples and oranges. The finite refers, part of the word, that adjective, refers to the earth, to the structure. The unbounded part refers to a verb, to the fact that something is incessant. They have turned that perpetual, that incessant walking into unbounded, limited, like if it's structurally limited. And that's the issue. The issue is that in this case, words are important. You need to absolutely define these terms and find out what they're addressing. Are we qualifying an object, or are we qualifying motion? And if it's an object, we'll call it an adjective. And if it qualifies motion, we're going to call it an adverb. So incessantly, moving incessantly, that's an adverb. Unbounded, that's not an adverb. That doesn't refer to motion. Unbounded is a word you have to use with objects. Unbounded is like finite. Okay? So words like finite, unbounded, discrete, those have to do with objects. Adverbs qualify verbs. That's why it's important to keep the language straight here, because they get off with a sleight of hand here. Very interesting sleight of hand. Okay, but the big problem that Larry Krauss had is that, or maybe a more fundamental problem, was that he did not come up with any of this. He said, positive energy, negative energy, they get together and they create no energy. And vice versa, you have this no energy, which is apparently equivalent to empty space, which is not empty. And these two particles can disassociate themselves, become virtual particles, come into the world momentarily, and then go back to be in space again. Okay, so what does that have to do with the universe? Well, the origin of the universe, according to mathematicians, could have started in the same way. Could have started from a point where you had negative energy, positive energy, they got together and they created no energy. And so now you have no energy, that's your starting point, which is made out of positive and negative energy. They split up and they form the universe, which is, made of gravitational and massive energy. So, okay. So what's the problem with that? Well, the problem with that is that he wasn't the first one to come up with it. We have a testimony from Mr. Stephen Hawking, and he said, the Big Bang itself, right? The universe was thought to have zero size, and there were tons and tons of particles in the region of the universe that we can observe. And the question is, where did they come from? And the answer is that the particles came out of energy in the form of particle-antiparticle pairs. So he's already saying the same thing. This book was 1988, so he's saying this many years, 30 years before Larry Krauss said it. So now, why would you go out there and buy Larry Krauss's book if someone's already said this in an older book? And when you dig deeper, you find out that even Hawking wasn't the first one to say this. You go back and you find this fellow. He's the guy who came up with this notion first. And he wrote a book in 1934. His name is Richard Tolman. There you see him with Albert Einstein in 1932, about a couple of years before he published his book. And he's the first person to document and explain how a closed universe could equal zero energy. He explained how all mass energy is positive, and gravitational energy is negative, and they cancel each other out, leading to a universe of zero energy. And of course, Mr. Tolman reversed that process and it ended up with the universe we have today. So, and that was 1934. So even Stephen Hawking, who put that in his book, like, oh, look, I've got news for you. Well, it wasn't news. It was olds. Tolman had already done that 50 years before Stephen Hawking did. So this idea has been floating around for a while. And again, there's no reason to buy Larry Krauss's book because this is old news, okay? It turns out, there were other philosophers who were discussing already this issue about nothingness. And here I gave the example of two of these fellows, and they're pretty well known. One is Victor Hugo, and the other one's William James. And they were philosophers, writers of the 19th century primarily. They already asked these questions. Victor Hugo said there's no such thing as nothing. And William James asked, why is there something instead of nothing? So these ideas already were floating around. People had already discussed them for quite a while. Okay? They're not new. And if you take it even further back, you find out that even Aristotle had already mentioned all this. He writes in his book 4 about, what is essentially nothing, or he calls it place, location, you could call it, position. And he just wanted to know if there was such a thing as place, absent, the object that occupied that place. And he goes through this analysis, and he eventually comes up with the idea that, he's got several arguments, but his main argument is that, there's no such thing as nothing, in other words, place or location or position, because as soon as you remove something from that place, something else takes its place. So he says the entire universe is in this floating or flowing thing where nothing is replaced constantly by something, and so there is no such thing as nothing because we never allow for there to be a nothingness. Something occupies that nothingness, and so at this point you have to ask, is there anything such as nothing? And some people with big credentials answer that essentially there isn't. And I have a couple of those testimonies. We have Mr. Laughlin. He's a Nobel Prize 1998. And he wrote in his book, A Different Universe, Reinventing Physics from the Bottom Down. And he says the modern concept of a vacuum of space, confirmed every day by experiment, is a real relativistic ether. But we do not call it this because it's taboo. So he does talk about the ether. He says we never really got rid of the ether. And just in case we had, a few years before that, like 80 years. I'm sorry, what is that? 80 years, almost 80 years. It says we may say, we have Einstein. He gave a chat at the University of Leiden. And he said we may say that according to the general theory of relativity, space is endowed with physical qualities. He says space has physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable. Okay, so mathematical physics in general, whether you talk about quantum mechanics, particles coming in from the void, or you talk about, general relativity, they rely completely on an ether theory. By ether, I mean that space is equated to either, you can call it a bunch of particles, it's something. There is no such thing as nothing in either general relativity or quantum mechanics. Okay, so what does this mean? It means we have to go back in time and figure out, where all this came from. We just saw that Aristotle already discussed a little bit about this, and it turns out that, all these Greeks, the ancient Greeks, they discussed the ether. Okay, they discussed the ether, and also they discussed the issue of infinity. We did not invent these in this day and age. These are not new concepts. They've been around for at least 2,000 years, more in fact. People wondered, especially philosophers. They were all rich folk, and they would look out at the heavens, see the stars, see a little bit of movement, the planets, the moving stars. And they said, what is this universe? Why are we here? What is all this about? So they started asking questions. They tried to answer those questions as best as they could within their world, limited knowledge, limited brainstorming that they had in those days. They didn't even know what the world looked like. They didn't know if the world was flat or round. Round meaning spherical. Um, you know, they were still pulling at straws, but they gave it their best shot. And you could say, well, it was a good starting point. Okay? Nothing wrong with that. You start out and you make a lot of errors. And they did make a lot of errors. So I'd like to go over a little bit of this. First, we have in Greece, where the origin of philosophy essentially began for the Western world. And that's important to note because, the Easterners, especially not so far east like India or China, which also had their own cultures, their own philosophers, their own physicists. But you just go to Sumerians, to the Babylonians, to the Egyptians, and they already used a lot of these concepts. And, it's up to you whether you believe that the Greeks reinvented them or borrowed them. You have to remember the Greeks traveled quite a bit and they did trade. And, so they heard things, they saw things, and they brought these ideas back to Greece and then they discussed them. So, did they come up with all these theories, mathematical theories, geometric theories, the geometry that we got from Euclid and so on? Well, I doubt it. I doubt it very much because, just think about one thing. The Sumerians, especially the Babylonians that came later, they built structures. They knew what a triangle was, and they built structured before Greece was even, like Athens. We always talk about the golden age of Athens. But you're talking about maybe 500, 400, 300 years before Christ. These guys were already, 600 years before Christ. Babylonia was the major empire. They had big buildings. Someone had to build them, some architect. You had to know a little bit about triangles, cubes, spheres. So I'm sure that they developed some geometry. If a lot of that wasn't written down, well, who knows? Sometimes we can't find everything that they had. We've got little bits and pieces of what was out there, and but I have to believe that all these cultures already had uh, some knowledge of geometry. Think about the Egyptians alone. Cheops, he goes back, 2,600 years before Christ. 2,000 years, over 2,000 years before you get people like Pythagoras and some of the other classical Greeks. For 2,000 years, before that, they had already built the first pyramid. And a pyramid is quite a structure, and it's triangular, conic. It's like a cone, like a pyramid, and so they had to know a little bit about geometry, I'm sure. So you got to keep these things in mind when you analyze all this. Okay. Anyways, where did all this start? Well, the Ionians, especially the ones from Miletus, little town in what is today Turkey. These people were pretty strong in their notions of mathematics, and they started building a philosophy based on some of this mathematics. They also were in touch with the Persian Empire, and even before that, for sure, they were in touch with the Babylonian Empire. So they already had some influence. And the first guy that appears considered, you could say, the father of Western philosophy, and that's Thales of Miletus. And wrong guy. Let's get this other fellow here. Keep getting the wrong one there today. It's this guy over here. And you can see here that Thales, here you have the little map. They were Ionians. They were all those islands that you see right off the coast of Turkey. And Miletus was a big town in those days. And these people like Thales, he founded the Ionian School, and they discussed these issues, especially about the origin of the universe and whether there was an ether and whether ideas of infinity started popping up in their minds, and they started discussing these things in their schools. And this Thales, he had a few of these fellows here. Where is he? The Ionian philosopher here, and these people wondered, among other things, whether the Earth stood on something. And again, they already had this idea of the ether, and they had the idea of the four elements, especially. And they couldn't really put it all together, but they wondered whether the Earth was sitting on some of these things. What was the Earth sitting on? Sometimes they would find, for example, that there were earthquakes, and they had to explain stuff like that. And so Thales was the idea that what constituted it all, the source of everything, what underlie the earth and everything really, was water. And he felt that the earth could move a little bit within that water, like floating. That was his idea. Anaximander, who was a contemporary of his, he believed in the Pyrrhon, and that's the infinity, the unlimited. And again, the question is whether he was referring to, an infinite object or incessant motion, what he had going through his mind. And a lot of these people were talking about math, the fact that you can count incessantly in both directions, that kind of thing. That's what they had in mind. Anaximander also thought that this substance, the apeiron, whatever he thought about it, was divine, immortal, eternal, and indestructible. So he had this idea of infinity in the back of his mind. Anaximenes of Miletus also, he thought the earth stood on air because he said, things floated in air. He thought that maybe the earth floated on air. And Heraclitus, he thought it was on fire, that the earth sat on fire. And so they had these discussions, which ones of the chemical elements was the earth sitting on? And again, they tried to figure out also what was out there, outside the earth. What were those things like stars? What were they sitting on? So, they had a view of the universe, and they tried to give it an explanation based on the four elements known at the time, plus the ether. By the way, the ether was already considered by the Orientals. You find this in the Upanishads. They already talked about space as a fifth element, and I guess they were referring to this notion of ether as well. Okay, so one of the fellows that was part of the Ionian culture. Let's see here. I get it again. Of the school of the Ionians, right? Um, was let's see. We have, yeah, no, I'm saying these were Anaximander, Anaximenes, and Heraclitus, and those people discussed, what the Earth was sitting on, that sort of thing. But then there was this other group of Greeks that came right after, and they were people such as Pythagoras and Xenophanes, and these people also took what they inherited from the Ionians and they started modifying these things. And Xenophanes thought that the earth really stood on infinity. He had this idea like an Anaximander. Whereas the Pythagoreans, they had different ideas. They didn't exactly agree with this infinity stuff altogether. They thought it was too loosely defined. The main exponent is Pythagoras. Obviously, he was from he set up his school in Croton. He was from Samos, but he set up his school in the southern tip of Italy, and he began the Pythagorean School. And again, you know about the Pythagorean theorem. I doubt very much he was the originator of that because we're talking about, in the 5th century here, BC, whereas, these concepts already came from as far back as the Egyptians and probably the Sumerians. But he set up his school at the bottom of Italy, and he was like a monk, because he lived an austere life, even though he came from a good family. He was a vegetarian. He didn't like to kill animals because he felt that the soul of men dwelled in them. Men who had misbehaved in their previous lives went to become, the souls of animals. So if you killed an animal, you were kind of killing a human. You were hurting his soul, or so to speak. And so he had this idea of reincarnation, which I think also came from the East. I doubt very much that he reinvented this. This probably came from the East. But anyways, he founded his school over there in Croton, and one of his followers was this guy on the right, Philolaus of Croton. He's going to kind of summarize what the school of Pythagoras came up with. And that was looks something like this. This is their universe. This is the way they saw the universe. Okay? And the way they saw it is that there was a fire somewhere in the center, and the earth revolved around that fire. There was another twin earth called the counter earth, was on the other side of that fire. We could never see it. It was like a seesaw where they both twirled around the fire and couldn't see each other. And outside of that, well, were the rest of the planets and the sun and everything rolling around that fire. So they had this different idea of, how the universe behaved, that we're going to modify in centuries later. But the interesting part is not only they had an internal fire, they had an outer fire, and that was there out beyond the stars. And again, where did the stars sit? Well, you can think of this as that idea of ether that was building up. Whether these folks talked about the ether, it's unclear, but for sure, the idea that the stars out there were sitting on some kind of medium or floating or flowing through it. This was already in the works. People were thinking in those terms. Parallel to these guys, or that some that came after, right, are these folks at the bottom, where you see Parmenides and Zeno. You've heard of Zeno. And Zeno is the guy who comes up with the Achilles and the tortoise. Uh, uh, what is it? This it's not even a fable. It's a like a test for infinity. Okay, he says there's infinite locations between Achilles and the turtle, or the tortoise. And so, he's got to cover all those locations before he can get to the turtle. And so infinity was in their minds. They were talking about infinity, and their school was known as the Iliadic School, and you can see there where it is. The Iliadic School was over there near the boot of Italy. Okay, here you have a better picture of that. And Ilia was founded by the Phocians. They traveled around the 6th century, really, to Velia, to modern day Velia. They founded this town, Ilia, and they went all the way to Spain to a place called Emporium. If you heard the word Emporium, well, now you know where it comes from. It comes from Emporium, which was a trading place. That's what it means. Emporium means trading place. Also meant merchandise. From there, they founded Massalia, which is modern day Marseille. And but anyways, Parmenides founded the Eleatic school, and Parmenides, Zeno, and Melissus were the primary exponents of this idea. But then they said something cannot come from nothing. This is you can say in a nutshell what they believed in. Therefore, whatever is has always been. So there's this idea of eternity again, but the question is whether it's referring to an infinite object or an eternal object. Are they talking about shape or are they talking about time? And this is where language is important because these people, as you will see if you look at their works, go back and forth between concepts and object, and you don't really always know. Are they talking about objects or are they talking about concepts? Are they talking about time? Are they talking about motion? What are they talking about? And whenever they give an explanation, they jump and give the wrong example. They might talk about infinity and then go with numbers, for example. Or, same thing. They might talk about walking, motion. And they had this idea that motion was eternal, time was eternal, numbers are infinite, whatever that means. That means unending. But then the question is, how did that relate to physics? Are we talking about an object being, finite? And this is where, language really becomes important. Okay, so one of the questions comes up because they had this idea of the ether that, as you can see, Einstein and the modern fellows, um, have brought back up to life. They can't get rid of the ether. By ether, I mean, that space is something. What is that something? Well, it's a bunch of particles in quantum. In relativity, they had to make space into some kind of trampoline. What it's made of, we don't know. We don't care about those things. We don't deal with those issues. We just have to explain what we observe, and the way what we observe is what we can describe with equations. And the equations tell us, the mathematicians, that a planet weighs down through its mass, right? Uh, the canvas of space time. So again, they turn space time into an object. So whether you talk about quantum or relativity, they all deal with a physical space, the ether. Okay? So where did this ether come from? Well, we have several ideas here. Like I said, the Upanishads already mentioned space, and that's the ether because they say from space came air, from air fire, from fire waters, waters the earth. So we have the four elements plus space. They were referring to the ether. Anaxagoras, again, he comes up and he mentions the ether. Air and ether covered all things, both being unlimited, again, infinite, right? For these are the greatest among all things, both in amount and in largeness. Okay, so he had this idea that there's some called ether out there. Plato mentions it also in his Timaeus, and he says right at the bottom there, it says, there are similar differences in air, of which the translucent kind is called the ether, and the most turbid sort mist and darkness. So we have a translucent ether and a turbid, a dull, dark ether. Aristotle, who is his student, he's got a little different idea of the ether. He agrees that there's an ether, but unlike Plato, he puts the ether not here on Earth. He says we don't get to see the ether because the ether is just what's out there behind the moon, between the stars. So the ether for Plato is just another of the fifth element, another of the elements here on Earth. Whereas Aristotle puts it outside of human bounds. He says, this is for the gods. This is not for us. And he writes about it on the heavens in one of his books. Okay, here's the fight between them, synthesized. Plato essentially, again, says there are the ether is the fifth element here on Earth, and all these people essentially got it from their teachers. They didn't invent it. They just used what had been what had been passed down through the centuries. We're talking about here maybe 200 years after and Thales and the Ionian school already were discussing the ether. So these two fellows, Plato and Aristotle, they're discussing something that they inherited, and they were just trying to give it some more meaning. And you can see what Aristotle does. He's giving it some characteristic. He does a thorough analysis of ether and just says, look, it's out there where the gods are. You can see it in that picture. The cloud, that's Mount Olympus. That's only for the gods. That's where the ether is. It's not here on Earth. And he says, look, I'm going to give it some qualities. And the earth and water are cold, air and fire are hot, but the ether is a divine substance. So he gets this from Anaximander also. You know, um, today they think that what he was really referring to are the four states of matter: solid, liquid, gas, and plasma. And who knows what ether is? I guess the relativists and the quantum mechanics, they haven't discovered what properties they give to the ether that is outside of the four states of matter. So that's something you should keep in mind. Find out, if some of these things, if some of these things are, if we can find a fifth element. So far, we've got the four states of matter. We don't have a fifth state, as far as I know. I mean, plasma is where they stopped, and I don't know. They might come up with something else later on, some new invention. But they say that those four elements is what Aristotle was referring to, the states of matter. That's what they perceived, and maybe they're right. Maybe that's what he had going through his mind. Okay. Okay. One good question is whether the ether is infinite. Because, you can ask if nothingness is infinite, but then the answer is nothingness doesn't exist. Okay, what exists? Well, what exists is the ether, some kind of ether, some kind of, I don't know, bunch of particles, a fabric of space time. Any of those is fine. Okay, fine. You put a physical object there. And so the question is that object infinite? And so you had to get to the word infinite. What are you referring to when you say infinite? Are you referring to incessant walking, incessant time, perpetual time? Or are you referring to the shape of an object? I mean, is space time, does that have a limit? Does that have a boundary? And if so, what continues? And that's more or less what these people were saying. You have space out there, and that's ether. Aristotle, right? Okay, so one question was the question of infinity. And again, you have an analysis by Plato and Aristotle, and they had a little fight over this. Remember, Aristotle was Plato's pupil, right? And then he founded his own school, the Lyceum. Plato had the academy, okay, both of them in Athens. And Aristotle says, the has two different kinds of uh, infinities. One is the potential, and the other one's the actual. Right? So he had these two notions. And by the way, if you read Aristotle, he develops these notions quite systematically. You don't have to agree with them, but what I'm saying, he does take the trouble to analyze them systematically, and you could say in a scientific way. Okay, so that you have to give Aristotle, his 10 points. And he says, look, the fact that the process of dividing never comes to an end ensures that this activity exists potentially. Okay, so he says that division, if you divide something up and you chop it off, you can chop it off eternally. Okay, keep chopping in half and half and half all the way, and you'll never end. Democritus, whom I didn't mention, he said, no, there's a limit. There's something called a particle that makes everything else. That's the idea he had. Whereas Aristotle is saying, look, you can continue dividing things eternally. And in that sense, infinity exists, but it's a potential activity because we cannot hope in reality to cut, the apple so many times. After a while, you don't have the actual cutting process. You can't continue. So all you have is, you have to do it with your mind. You have to do it with thought. Okay, you have to do a thought experiment. In that sense, he was referring to the fact that it's potential. You can conceive of it. On the other hand, he says that you cannot go in the opposite direction. Um, if you try to add or multiply, like if you're going in the upward direction, you want to go from 1 to 2, from 2 to 3 to 3 to 4, and all the way upwards to infinity. That's not possible. That's not even possible potentially or actually. And why? Because he says what happens there is that he says first he says what is continuous is divided ad infinitum. And I disagree there. If it's continuous, it can't be divided. That's what continuous means. But let's continue. But he says, but there is no infinite in the direction of increase. Okay, so in the positive direction, there is no possibility of infinite. He says, why? For the size which it can potentially be, it can also actually be. Hence, since no sensible magnitude is infinite, it is impossible to exceed every assigned magnitude. For if it were possible, there would be something bigger than the heavens. In other words, what he's saying here, Aristotle is saying, look, you cannot have something that is bigger than the heavens. You cannot have positive infinity, because that would mean that the number or the thing or the time or whatever you want to call that infinity exceeds the limits of the heavens. And he could not imagine that, because he says, I guess in his mind, he thought that heaven was not infinite. So if heaven had a size, so to speak, right, you cannot have a number or a thing that exceeds the size of heaven. That was his reasoning, okay, which was, I thought quite amusing. But on the other hand, he says, time indeed and movement are infinite. So you wonder what he was referring to. Was he referring to a physical object when he says actual? Yeah, I guess he was. And that's his criticism against Plato. He says that, Plato mentions great and small infinities. The small meaning dividing things until you get to the tiniest. And the great is in the positive direction. You can have positive infinity. And that's where Aristotle corrects them and says, you can't have really a positive infinity, at least as far as object, or even in counting objects, the number of objects. Because, if the number of objects in the universe is greater than heaven, he could not make that fit into his philosophy. He says, nothing can exceed the size of heaven, because heaven is like universe, it's everything. And you can't have the number of things be greater than heaven, and you cannot have a single object be greater than heaven. And and he also, because he did it with numbers, and he says, look, you cannot have numbers that, because I guess he's saying you cannot have all these numbers and exceed the capacity of heaven. You cannot have trillions and trillions of numbers, because where would they fit? That's what he was thinking. On the other hand, he says time, oh yeah, that can be infinite. And motion too. Why? Because again, he's talking about incessant, not about infinite. And that's why you have to keep these words, you really have to define them and know what you're talking about when you're doing this. Okay? So this is where some of the problems arose. Okay, what happened with all this? Well, the thing didn't stop there. After Aristotle came up with his notion of the ether being out there and not here, it's like the ether belongs to the gods. It's out there beyond the moon, it's out there between the stars. It's where the gods dwell. It's not here on earth. We'll never see it. We'll never breathe it. We'll never see it, And some people, I guess, were not satisfied with that. They said, look, they started identifying the ether with the soul, like saying, the souls belong to the gods, and these souls come from the stars and they penetrate our bodies. We kind of acquire the soul from the stars, from this ether that's out there. And so they started bringing the ether back into earth. and the ether became more a religious issue. The ether was starting to be identified with the soul, with the spirit, with the mind, with conscience. And so they used the same word, ether, to refer to that more and more over time. And you've got some philosophers. I got a little disconnection on the chat. I don't know what's going on there. Okay, where was I? Here you have the people who came after um, Aristotle, and you have Zeno, but he's a contemporary of Aristotle, not the same Zeno as the one from the Eleatic school. And he founds the Stoicism. He's a Stoic, and he identifies ether with divine fire. Okay, so he's saying that he goes back to this idea that Heraclitus had, that ether was really some kind of fire. It's different. It's not fire like earth, water, air, and fire, but it's a different kind of element. But he said it's a divine fire. And again, I'm not sure if that would changed anything, right? Chrysippus comes to almost 300 years. I'm sorry, yeah, before Christ, and he comes up also identifying ether now with the soul. He invents the notion of pneuma. And again, he takes this idea from Zeno that the sun is pure fire, and the moon is fire plus air, which is also some kind of divine fire. So they're all more or less on the same wavelength. These guys are trying to get the ether back, and I guess they're disagreeing with Aristotle, who says, ether belongs to the gods. They're trying to bring the ether back in. Plotinus, he comes up in the Christian era, third century, and he says, he mentions it, that the ether is essentially the vehicle of the soul. Okay, so he brings this ether from space, from, from the ether, from the identification of ether with space. He brings it back into Earth almost officially. And they forget about Aristotle. And around the same time, you'll find a little later, but around the same time, you'll find St. Augustine, who also identifies it with the soul. One of the few guys that identifies it still out there with something that's out there in space is this astrologer Martianus, and he writes a book in which he again brings Aristotle somewhat back. He says, look, the Earth is there; it's surrounded by water, by uh, you know, what is it? Fire, air and fire, and eventually the ether. So there was a trend to get the ether more and more um, into identified with the soul. Okay, so it stopped being, you could say, part of science. The ether kind of drifted into religion, and so what this did was turn the ether into this thing that was covered mainly by religion. And the astrologers would talk about the ether, but mainly the ether was turned into the soul. That was the substance from the stars that penetrated our bodies and became the spirit, the mind of man. Okay, so what comes out of all this? Well, what comes out of all this is that eventually the this was the ether was brought back by the so-called scientists, the mathematicians, and that wouldn't happen until the 17th century when they started bringing back the ether from the astrologers and the alchemists who were talking about the ether but doing religion, and also religious folk who were using the ether as a synonym of the soul. And by the 17th century, now the ether goes back into, we'll call it science, for lack of a better word. The mathematicians borrowed that concept or reignited that concept, and because they needed to know what light was, they said, "What is this thing called light?" And so we get to Christian Huygens, and we get to um, Isaac Newton. Even before then, we had Hooke, Robert Hooke. He talked about waves. They were thinking of longitudinal waves. That's what Huygens is going to describe. And they're going to talk about the ether. They're all going to talk about the ether. And they're all going to imagine it as a bunch of vibrating particles, essentially. And we're going to see how these guys differ from each other, next time around. But meanwhile, let me do a little summary of what I covered. And we got the following, let's put it in the right context. The ether is still alive and well today. People like Larry Krauss, who identify nothing with something, and that's been going on at least for the last 100 years. He's not the only one. Aristotle's ether, that was an eternal substance of the gods. Essentially, he said, that it's something that's out there in the cosmos. It's between the stars. It's not here on Earth. But the writers, even contemporaries of his, and those that came after him, they gradually morphed that into the soul, and they brought it back into religion, which was where it started. In the days of the early philosophers of Greece. They kind of had this idea that the ether was related to the soul. Well, that idea was brought back. And then the question was the word infinite. And they dealt with that issue, not in terms of the ether, but they imagined, I guess, that the ether was infinite. Some said no, because, it had to have a starting point. And then the other guys would say, well, something cannot come from nothing. And they got through all these arguments, right? But then the question is valid: is the ether infinite? Is assuming it's nothing, is nothing infinite? We have to try to answer these questions because they pertain to physics. If you're going to use a medium and you're going to say, look, this is what light is, this is what gravity is. Okay, what is it? Well, it's the ether. Okay, is the ether infinite? I mean, or does it stop somewhere? The space-time stop somewhere? If so, what continues? Those questions are all valid questions. And the Greek infinity, like the mathematical infinity of today, is unrelated to physics. Why? Because, these people apply it to concepts. And when you apply it to things such as motion, time, life, heaven, counting, these words, well, then you're not talking about infinity. You're talking about incessant motion. So again, you're applying it to verbs, to concepts, dynamic concepts. Right? Aristotle, he claims the infinity cannot exist in Plato's great sense because it would be bigger than heaven. That was his main argument. He has some other arguments in his physics book number 3. Yeah, so if you want to look it up. And he distinguished potential concept from actual concepts, from actual objects. In other words, he said, the actual object cannot be infinite, which is essentially my point of view. In that sense, I'm Aristotelian, you could say, saying objects cannot be infinite. And he's also got this notion that, the number of objects cannot be infinite. So that's another thing you should throw in there. But on the other hand, he says there's potential infinity, which he's referring really to not only incessant motion, but he's also referring to incessant counting. And he says that's potential but not real. So with that, I'm going to see you on Sunday, and I'm going to continue with this. Now we're going to start with some exciting stuff. We're going to find out what the people in the 17th century started doing with this famous ether stuff and how they try to explain light. And from there, we're going to work our way to the 19th century and find out what a big mess they made out of the ether. And as you can see, it's still alive today. We still have ether to this day. We'll see you on Sunday. We'll see you then.